Solar panels are a great way to harness renewable energy from the sun. They work by converting sunlight into electricity using photovoltaic cells, which are typically made of silicon. When sunlight hits these cells, it excites electrons, generating a flow of electricity. Solar panels have become increasingly popular due to their environmental benefits and the decreasing cost of solar technology. They can be used in various applications, from residential rooftops to large-scale solar farms. Here are the complete steps for solar panel installation, from the assessment and planning to the final wiring. 1. Site assessment and planning. Determine the best location for solar panel installation based on sunlight exposure, shading, roof orientation, and local regulations. Assess the roof's structural integrity and suitability for solar panels. 2. Obtain permits and approvals. Obtain necessary permits and approvals from local authorities, homeowner associations, HOAs, and utility companies. Ensure compliance with building codes and regulations. 3. Design system layout. Design the layout of solar panels based on available space, energy requirements, and efficiency considerations. Determine the optimal tilt and orientation of panels for maximum sunlight exposure. 4. Acquire materials and equipment. Procure solar panels, mounting hardware, inverters, wiring, connectors, and other necessary equipment. Ensure all materials meet quality and safety standards. 5. Install mounting structure. Install racking or mounting structure on the roof or ground to support solar panels securely. Follow manufacturer guidelines and engineering specifications for proper installation. 6. Install solar panels. Attach solar panels to the mounting structure using bolts, clamps, or brackets. Ensure panels are aligned correctly and securely fastened to withstand weather conditions. 7. Install inverter and electrical components. Install the inverter near the main electrical panel or at a designated location. Connect the DC wires from solar panels to the inverter input and the AC output to the electrical panel. 8. Grounding and wiring. Ground the solar system according to local codes and safety standards. Route DC and AC wiring from solar panels and inverter to the electrical panel, following proper conduit and wiring guidelines. 9. Connect to grid or battery system *. If grid-tied, connect the solar system to the utility grid through a grid-tie inverter and appropriate metering equipment. If off-grid or hybrid, connect to battery storage systems or other energy management components. 10. Commissioning and testing. Perform system testing, including voltage checks, insulation resistance tests, and commissioning procedures. Verify proper functioning of all components and ensure safety measures are in place. 11. Final inspection and approval. Schedule a final inspection with local authorities or utility representatives to verify compliance and safety. Obtain necessary approvals and permits for grid connection or system operation. 12. Monitoring and maintenance. Set up monitoring systems to track solar system performance, energy production, and potential issues. Establish a maintenance schedule for regular cleaning, inspections, and servicing as needed. Following these steps ensures a systematic and safe solar panel installation process, from setting up the stands to completing the wiring and commissioning of the system. We're going to talk about site assessment and planning for solar panel installation. This is a crucial step in ensuring the effectiveness and safety of your solar energy system. Let's dive into the key aspects of this process. Firstly, we need to determine the best location for solar panel installation. This involves assessing sunlight exposure, shading, roof orientation, and local regulations. Sunlight exposure is critical because panels need direct sunlight to generate maximum power. We use tools like solar path maps and shading analysis to understand how shadows from nearby structures or trees may impact panel performance throughout the day and across seasons. Next, we consider roof orientation. Ideally, solar panels should face south in the northern hemisphere and north in the southern hemisphere to receive the most sunlight. However, east or west-facing roofs can also work with adjustments in tilt angles.
Local regulations play a significant role in solar panel placement. Zoning laws, building codes, and homeowner association rules may dictate where panels can be installed, their tilt angle, and even their appearance. It's crucial to work with local authorities and adhere to these guidelines to avoid any legal issues. Moving on to the second aspect, we assess the roof structural integrity and suitability for solar panels. Not all roofs are created equal when it comes to supporting the weight of solar arrays. We conduct a structural analysis to ensure that the roof can handle the additional load of panels, racking, and any potential snow or wind loads in your area. Factors like roof age, material, slope, and condition are considered during this assessment. For instance, a newer roof with sturdy materials like metal or concrete tiles may be more suitable than an older roof with asphalt shingles. In conclusion, site assessment and planning are essential steps in the solar panel installation process. By evaluating sunlight exposure, shading, roof orientation, local regulations, and structural integrity, we can design a system that maximizes energy production while ensuring safety and compliance.
Now I am going to discuss the crucial step of obtaining permits and approvals for your solar panel installation project. This process involves working with various authorities and organizations to ensure compliance and smooth execution. Let's delve into the key aspects of this phase. Firstly, we need to obtain necessary permits and approvals from local authorities, homeowner associations, HOAs, and utility companies. Local government agencies typically require permits for solar installations to ensure that they meet safety, electrical, and structural standards. These permits may vary based on the location and scope of the project, so it's essential to research and understand the specific requirements in your area. Homeowner associations, HOAs, often have their own set of guidelines and approval processes for external modifications like solar panels. It's important to review your HOA's rules and submit any necessary applications or documents for their approval before proceeding with the installation. Utility companies also play a role in the permitting process, especially regarding grid-tied solar systems. You may need approval to connect your solar panels to the grid and participate in net metering or other incentive programs. Contacting your utility early in the process can help streamline these approvals. Secondly, we must ensure compliance with building codes and regulations. Building codes are in place to safeguard structural integrity, electrical safety, and overall building standards. Solar panel installations must meet these codes to ensure a safe and reliable system. Common areas of compliance include roof load capacity, electrical wiring standards, setback requirements, and fire safety measures. Working with a qualified installer who is familiar with local codes can greatly simplify this process and prevent costly mistakes. In summary, obtaining permits and approvals is a critical step in the solar panel installation journey. By working closely with local authorities, HOAs, and utility companies and ensuring compliance with building codes and regulations, we can ensure a successful and legally sound installation. Now, I am going to discuss the important phase of acquiring materials and equipment for your solar panel installation project. This step is crucial for ensuring that you have the right components to build a reliable and efficient solar energy system. Let's dive into the key aspects of acquiring materials and equipment. Firstly, we need to procure the necessary components, including solar panels, mounting hardware, inverters, wiring, connectors, and other essential equipment. Solar panels are the heart of your system, responsible for converting sunlight into electricity. It's important to choose high-quality panels with appropriate wattage and efficiency ratings based on your energy needs. Mounting hardware such as racking systems and mounts are used to securely install solar panels on rooftops or ground-mounted structures. These components should be durable, weather-resistant, and designed to withstand the specific conditions of your installation site. Inverters are another critical component that converts the direct current, DC, electricity generated by solar panels into alternating current, AC, electricity used in homes or businesses. Selecting the right type and size of inverters based on your system design is essential for optimal performance. Wiring and connectors are necessary to interconnect solar panels, inverters, and other system components. These should be rated for outdoor use and comply with electrical codes and safety standards to prevent hazards like overheating or electrical faults. Secondly, we must ensure that all materials and equipment meet quality and safety standards. This includes checking for certifications such as UL, Underwriters Laboratories, listings, or other relevant industry certifications. Quality assurance ensures that components are reliable, durable, and perform as expected over their lifespan. Safety standards are paramount in solar installations to protect both installers and end users. Components should comply with electrical safety codes, fire safety requirements, and any applicable building regulations. Working with reputable suppliers and manufacturers can help ensure that you receive compliant and reliable equipment. In summary, acquiring materials and equipment involves procuring solar panels, mounting hardware, inverters, wiring, connectors, and other necessary components while ensuring they meet quality and safety standards. By selecting high-quality components and adhering to safety protocols, we can build a robust and efficient solar energy system. Now, I am going to dive into the process of designing the layout of a solar panel system. This step is crucial for optimizing energy production, space utilization, and overall system efficiency. Let's explore the key aspects of designing a solar panel layout. Firstly, we need to consider available space and energy requirements. The amount of space you have available will influence the number and configuration of solar panels you can install. It's essential to conduct a thorough site assessment to determine the available roof or ground space for your solar array. Energy requirements play a significant role in determining the size of your solar panel system. Factors such as your electricity consumption, desired level of energy independence, and future energy needs should be taken into account during the design phase. This information helps us size the system appropriately to meet your energy goals. Next, we focus on efficiency considerations. This involves designing the layout of solar panels in a way that maximizes energy production throughout the day and across seasons. We consider factors such as shading from nearby objects, panel orientation, and tilt angle. Determining the optimal tilt and orientation of panels is critical for maximizing sunlight exposure. In the northern hemisphere, solar panels typically perform best when facing south, as this orientation captures the most sunlight over the course of a day. However, the optimal tilt angle may vary based on your location and seasonal sun angles. Shading analysis tools and solar modeling software help us assess how shadows from nearby trees, buildings, or obstructions may impact panel performance. By minimizing shading and optimizing panel placement, we can enhance the overall efficiency and output of your solar energy system. In conclusion, designing the layout of a solar panel system involves a careful balance of space availability, energy requirements, and efficiency considerations. By optimizing panel placement, tilt angle, and orientation, we can harness maximum sunlight exposure and improve the overall performance of your solar energy system.
Now, I am going to talk about the crucial step of installing the mounting structure for solar panels. This step is essential for securely supporting solar panels on rooftops or ground-mounted systems. Let's explore the key aspects of installing the mounting structure. Firstly, we need to install racking or mounting structure on the roof or ground to support solar panels securely. The type of mounting structure used depends on factors such as roof type, available space, local weather conditions, and project requirements. Common mounting options include roof-mounted racks, ground mounts, pole mounts, and tracking systems. When installing on a roof, it's important to consider the roof's material, slope, and structural integrity. Roof-mounted racks are typically attached to roof rafters or trusses using specialized flashing and attachment hardware. Proper waterproofing and sealing techniques are crucial to prevent leaks and ensure the longevity of the roof and solar system. For ground-mounted systems, concrete footings or ballast weights may be used to secure the mounting structure. Ground mounts offer flexibility in panel orientation and tilt angles, making them suitable for locations where roof space is limited or when optimal panel orientation is required. Secondly, it's crucial to follow manufacturer guidelines and engineering specifications for proper installation. Each mounting system comes with specific instructions regarding assembly, attachment methods, weight distribution, and load-bearing capacities. These guidelines ensure that the mounting structure is installed correctly and can safely support the weight of solar panels, withstand wind loads, and resist other environmental stresses. Professional installers are trained to follow best practices and adhere to industry standards during mounting structure installation. They use appropriate tools, equipment, and safety measures to ensure a secure and reliable installation. In conclusion, installing the mounting structure for solar panels requires careful planning, adherence to manufacturer guidelines, and attention to structural integrity. By choosing the right mounting system and following proper installation procedures, we can ensure that solar panels are securely mounted and positioned for optimal energy production.
Now, I am going to discuss the important process of installing solar panels, a key step in bringing your solar energy system to life. Installing solar panels involves precise alignment, secure attachment, and attention to detail to ensure optimal performance and longevity. Let's delve into the key aspects of installing solar panels. Firstly, we attach solar panels to the mounting structure using bolts, clamps, or brackets. The mounting structure, which we installed earlier, provides the foundation for securely anchoring the panels. Depending on the type of mounting system and manufacturer specifications, we use appropriate hardware to fasten the panels in place. Bolts are commonly used for roof-mounted systems, where panels are attached to rails or racks using specialized mounting brackets. Clamps or brackets designed for solar panels are used to secure the panels to the mounting structure without compromising their structural integrity. During installation, it's important to ensure panels are aligned correctly both horizontally and vertically. Proper alignment ensures uniform spacing between panels and allows for efficient wiring and connectivity. We use levels, measuring tools, and alignment guides to achieve precise panel placement. Secondly, we must ensure that panels are securely fastened to withstand weather conditions. Solar panels are exposed to various environmental factors such as wind, rain, snow, and temperature fluctuations. Secure attachment is crucial to prevent panels from shifting, loosening, or sustaining damage during adverse weather events. Proper torque settings for bolts and clamps, as specified by the panel manufacturer, are essential to ensure panels are securely fastened without over-tightening, which can damage the panels or mounting structure. Additionally, we use weatherproof seals and coatings where necessary to protect electrical connections and components from moisture and corrosion. Professional installers follow industry best practices and safety protocols during solar panel installation to ensure a reliable and durable system. They also conduct quality checks and inspections to verify that panels are installed correctly and meet performance standards. In summary, installing solar panels involves attaching them to the mounting structure securely, ensuring correct alignment, and implementing measures to withstand weather conditions. By following proper installation techniques and manufacturer guidelines, we can create a robust solar energy system that delivers clean and renewable power for years to come. Now, I am going to discuss the critical steps of grounding and wiring in a solar panel system installation. Grounding ensures electrical safety and compliance with local codes, while proper wiring is essential for efficient energy transfer and system functionality. Let's delve into these key aspects. Firstly, we focus on grounding the solar system according to local codes and safety standards. Grounding is crucial to protect against electrical faults, lightning strikes, and ensure the safety of both the system and occupants. Grounding requirements vary by location, so it's essential to follow the specific guidelines outlined in your local electrical codes. Grounding typically involves connecting the metal components of the solar system, such as frames, mounting structures, and inverters, to a grounding electrode system. This system includes grounding rods, conductors, and bonding connections that create a low-resistance path to safely dissipate electrical currents in the event of a fault or surge. Professional installers use specialized equipment and techniques to ensure proper grounding, including resistance testing to verify the integrity of the grounding system. By following industry standards and local regulations, we can establish a reliable and safe grounding system for the solar panel installation. Next, we address the routing of DC and AC wiring from the solar panels and inverter to the electrical panel, following proper conduit and wiring guidelines. DC wiring carries the electricity generated by solar panels, while AC wiring carries the converted electricity from the inverter to power your building's electrical loads. DC wiring from the solar panels to the inverter must be routed carefully to minimize voltage drop, ensure proper insulation, and protect against environmental factors. Wiring is typically run through conduit or raceways to provide physical protection and comply with electrical codes. Proper wire sizing and labeling are crucial to prevent overloading and facilitate troubleshooting if needed. Similarly, AC wiring from the inverter to the electrical panel follows specific guidelines to ensure safety and performance. Wiring paths are planned to avoid interference with other electrical systems and to comply with spacing requirements. Professional installers use appropriate connectors, junction boxes, and termination points to secure and organize wiring connections. In conclusion, grounding and wiring are essential elements of a solar panel system installation that ensure electrical safety, compliance with codes, and efficient energy transfer. By following best practices, adhering to local regulations, and working with experienced installers, we can create a reliable and high-performing solar energy system for your property. Now, I am going to discuss the crucial step of installing the inverter and electrical components as part of your solar panel system. The inverter plays a vital role in converting the direct current, DC, electricity generated by solar panels into usable alternating current, AC, electricity for your home or business. Let's dive into the key aspects of this installation process. Firstly, we install the inverter near the main electrical panel or at a designated location. The inverter is typically installed indoors or in a weatherproof enclosure, depending on local regulations and system design. Placing the inverter near the main electrical panel minimizes wiring distances and simplifies the connection to your building's electrical system. Next, we connect the DC wires from the solar panels to the inverter input. These DC wires carry the electricity generated by the solar panels and feed it into the inverter for conversion. It's crucial to follow proper wiring practices, use appropriate gauge wires, and implement overcurrent protection devices as per electrical codes. Once the DC wiring is in place, we connect the AC output of the inverter to the electrical panel. The inverter's AC output is connected to a dedicated breaker or circuit in the electrical panel, allowing solar-generated electricity to flow into your building's electrical system. This connection enables you to power your appliances, lights, and other electrical loads using solar energy. During installation, safety measures such as proper grounding, labeling, and testing are implemented to ensure electrical safety and system functionality. Professional installers follow electrical codes and manufacturer guidelines to ensure a compliant and reliable installation. After completing the physical installation, we perform commissioning and testing procedures to verify that the inverter is operating correctly and efficiently. This includes checking voltage levels, verifying proper functionality of monitoring systems, if applicable, and conducting performance tests under different load conditions. In conclusion, installing the inverter and electrical components involves careful planning, wiring, and testing to integrate your solar panel system with your building's electrical infrastructure. By following best practices and safety protocols, we can create a seamlessly integrated solar energy system that delivers clean and renewable power to meet your energy needs. Now, I am going to discuss the final steps of connecting a solar panel system to either the utility grid or a battery storage system, depending on the system type and configuration. This connection phase is crucial for enabling the utilization and management of solar-generated electricity. Let's explore the key aspects of connecting to the grid or battery system. Firstly, if the solar system is grid-tied, we connect it to the utility grid through a grid-tie inverter and appropriate metering equipment. Grid-tied systems are designed to feed excess electricity generated by solar panels back into the utility grid, offsetting your energy consumption and potentially earning credits through net metering programs. The grid-tie inverter converts DC electricity from the solar panels into AC electricity synchronized with the utility grid's voltage and frequency. It's installed near the main electrical panel and is connected through a dedicated circuit breaker. The inverter also includes monitoring features to track energy production and grid interactions. Metering equipment, such as bidirectional meters, tracks the flow of electricity between your solar system and the utility grid. This allows for accurate billing and credit calculations based on net energy consumption or production. On the other hand, if the system is off-grid or hybrid, we connect it to battery storage systems or other energy management components. Off-grid systems are independent of the utility grid and rely on batteries to store excess solar energy for use during periods of low sunlight or high demand. Battery storage systems store DC electricity from solar panels and release it as needed, providing backup power and enhancing energy self-sufficiency. Hybrid systems combine solar panels, battery storage, and grid connection to optimize energy management and resilience. The connection process for off-grid or hybrid systems involves integrating charge controllers, inverters, and battery banks according to system design and manufacturer specifications. Safety measures such as proper grounding, overcurrent protection, and system testing are critical during this phase. Professional installers ensure that grid-tied or off-grid connections comply with electrical codes, safety standards, and utility interconnection requirements. Commissioning tests are performed to verify system functionality, communication with monitoring devices, and seamless operation in different operating modes. In conclusion, connecting a solar panel system to the grid or battery system is a pivotal step in harnessing solar energy for power generation. Whether grid-tied or off-grid/hybrid, proper installation, connection, and testing ensure a reliable and efficient energy system tailored to your needs.